Okay, this is a little late, but I said I'd put together a skip list example using the full list of numbers that we did in the class on Friday. So here's the skip list example. So let's first of all talk about creation from scratch of the skip list. So here's our numbers and here's the algorithm. The first thing every time we want to insert a new number is we toss a coin and figure out how many heads we get. Okay, and then the bottom you can see, and it's partially hiding behind me, so let me just get out of the way quickly. Right, so you've got a minus infinity to plus infinity, and those two items, those two guards, the minus and the plus infinity, are in every level. Okay, so then we toss the coin, and I'm not going to show you me tossing the coins, but I just used the same website that I used on Friday, and I got 3 heads in a row, and then I got a tail, so our I is 3 for inserting number 12. So I had to add 4 more layers because I need to go up to level I plus 1. If I is 3, that means I need 4. And remember, the bottom layer is always level 0. Okay, so 0 through 4. And then I have to, there's nothing in there, so I have to put the 12 in those layers 0 through I. So there it is. And that's where it stays. Okay, and then I don't know what I was flipping really well when I did this, so I got a 4 heads in a row for 44. And what does that mean? That means I need to add yet another layer, right? So I need to a layer. The top layer has to be I plus 1, so I need total of 6. And then I figure out where in the skip list it needs to go, and I need to insert it in every level from 0 up to level I, level 4. So that's where the 44 goes. And then I got a 1 for inserting the 13, so I don't have to add anything, and I just have to insert the 13 on level 0 and level 1. And that's where it stays. And then I got a 6, right, which is way more than, I don't know what I was doing, but anyway, I got 6 in a row. So I had to add another 2 layers, and then my 88 gets inserted between the 44 and the plus infinity, and that's where it stays. Then I got none, so I don't have to add anything, and the 23 goes in between the 13 and the 44. And then my 94, I got a 0 again, and it goes between the 88 and the plus infinity. 11, I got 2, so I need to insert it on levels 0 through 2, but I don't have to add any more levels. And 39, I got a 0, and 20, I got a 0, and now I'm going to have to move things around a bit. I got a 0 again, so I have to move things around a little bit to slot 16 into where it goes, and then I got a 0 again on 5. Okay, so that is an example of inserting everything, and it's because of that randomness, because of that I, it's going to be different every time, right? You're never going to get, well, not never, but you hardly ever going to get the same skip list again. But the key piece about a skip list is that each layer should have, on average, half the number of items in it as the layer below it. And it's not quite there with this one, but you can see that maybe if we had a lot more items that it would statistically get there. So now the reason we want to use a skip list is because we're told it's quick for searching. And I don't think it'll show up in this small example. Right, so here's the search algorithm. And basically we start at the top left item, right? The minus infinity at the top left. And then we look at our current position and we get the next value, which will, in the first instance will be plus infinity. And we check to see if that value is greater than or is less than the one we're looking for. In this case, obviously, it's greater than, so we drop down. Right, so we drop down there. And then again, our next is 88. We're looking for 23, so we drop down again. Next is 88. We're looking for 23, drop down again. Next is 44. We're looking for 23, drop down again. Next is 12. Aha! So now we have to scan forward. So we scanned forward to 12. And then our next is 44 from 12, so we drop down again. 44 is still our next, so we drop down again. So then 13 is our next, so we scan forward. And then 44 is our next from 13 at level 1. So we drop down again to the bottom level. We can't drop any further. And by the time we get to 20, our next is equal to the thing we're looking for. So we're good. Now let's just think about how we compare that to traversal. So the skip list took, I think, 11 or 12 operations, right? There's the moves we did, either the drop down or the scan forwards. And I've enumerated them, there's 11 of them. If we had just taken the sorted list and traversed it, right, it'd be 7. So in this particular example, the skip list is not necessarily the best. But remember what a skip list is about. It's about dealing with large amounts of data quickly. So for small numbers like we have now, it doesn't necessarily make that much sense. So I went and looked up the original paper about skip lists because it's a relatively recent development. Okay, it's 1990, but that is a long time ago, 31 years, but it's still relatively recent in computer science terms. Right, so here's the table of timings. And what they did, you can see up in the text up in the top right there, the times in this table reflect the CPU time on a Sun 360 to perform an operation in a data structure containing 2 to the 16 elements with integer keys. And then the values in parentheses show the results. And you can see for every other sort of data structure, the only one that performed better was in the non-recursive AVL trees. Every other time in this table is bigger than what the skip list took for either search, insert, or delete. Right? So it's a pretty good algorithm. And again, on average, and we'll have to look at what the best case, worst case, and average times are in the lecture on Tuesday.